Hello everyone, welcome to AI Universe. So at this point of time, you might be having a lot of queries in your mind. So go seeing the last video, you might be like thinking like, what is what where, I mean LLM, where we are giving the input, where we are getting the output, and why where we are going to use Python in the artificial intelligence with respect to cybersecurity and all. Just want to clarify with respect to this solar system diagram. So this example would be like I believe that it will be easy for you guys to understand the flow. So let's take I in the previous video also I informed that uh, let's consider AI as a AI universe, okay? And then machine learning is one of the concept. Like sun, sun is very important to our solar system because all the planets depend upon our the sun. So then comes the Mercury, then comes the Venus, Mars, and then Earth and Jupiter, Saturn, and Pluto, Uranus. It goes on. It goes on like that. So let's see. You have considered the solar system or the universe. The universe as a artificial intelligence, and in that, machine learning is the sun. Machine learning is the sun, correct? Your machine learning is the sun, and other planets like Mercury, Venus, Mars, Earth are like respective algorithms or models used in the artificial intelligence. In this case, say for example, our first first planet or the first algorithm they come up with was linear model, which was developed by Frank Blanket. Frank Rosenblatt. So he was responsible for building that linear model, and that linear model was called perceptron. This perceptron was the breakthrough in the algorithm or the model which respect to the the complex task processing. So you can differentiate the algorithms used in cybersecurity into two. Let's say till here, till this planet, linear model, supervised learning, unsupervised learning. You can say you are going to use traditional AI or ML, whereas the next half the next half is generative AI, reinforcement learning, deep learning are like comes under like you are going to generate that particular thing. So this is like generative or creative or creation. You are creating, that comes under the Gen AI part. Reinforcement learning is something like you depend on the rewards and the feedback you get. Maybe we'll cover this later because we are going to go through like each model at the very best explanation, like concentrating on each video with an example or a use case in the upcoming session. But as of now, you just try to understand that these planets till this point of time, that is from linear model till unsupervised learning, you are going to use traditional ML, AIML, and for the from the earth, the generative AI, and then reinforcement learning, deep learning, natural processing. Those are all different. That use cases will be used for several other purposes. But at this point of time, we are a beginner now. We are a beginner in learning the artificial intelligence. So first of all, we need to know what is traditional AIML concept being used in the AI cybersecurity space, and then you have to come up for the generative AI, and then create generative AI and the reinforcement learning, deep learning, and natural language processing. So reinforcement learning, just to give an overview, it works on positive reward or feedback and negative reward or feedback. At this point of time, you might be not knowing like what is positive feedback or a negative feedback. We'll come up with that later. And deep learning, you make use of convolutional neural networks, recurrent neural networks. We have already discussed that convolutional neural networks is a use case example or the concept behind the self-driving cars, and recurrent neural networks is the use case behind another example I mean, image processing or the image fake image, deep fake identification. All uses recurrent neural networks. And natural language processing, you are aware that it's going to generate image, videos, and stuff. So these are like example. Now let's focus towards traditional AIML. So what does traditional AIML working in with respect to cyber security workspace? So now you are having a system, and most often you are going to run these AML with respect to cyber security with traditional AML concepts with a Linux based environment, mostly like Ubuntu. So you are running a Ubuntu OS. Inside that Ubuntu OS, you are going to install Python, and after installing the Python, you are going to create your Python program, your AIML Python program, along with Python libraries. Along with Python libraries of AIML especially used in cybersecurity. We will cover that Python libraries in upcoming session. So this is I'm talking talking about the workflow. So inside your machine, you are having Ubuntu OS. Inside that Ubuntu OS, you are having a Python program running, and you have a AIML program where you are using AIML libraries, Python libraries for executing that Python code. And say for example, your example of running or a scenario is, we discussed that to identify whether it's a spam email or a normal email. So that is our condition. So you are going to use that condition in that Python code to identify whether that is spam email or a normal email. This is the overall workflow with respect to understanding with respect to traditional AIML. Okay, so now the same finding the spam email or the normal email can be used with three algorithm or the models. We can use it like with three algorithms or the models. So either you can use linear model or supervised learning or unsupervised learning for this use case. I told you in the last class that it's up to you to decide which algorithm or the model, or which car or a bike scenario to travel that small roadway path. So initially when the AIML was introduced, you know that you are having linear model, but there is a drawback with respect to using linear model, because it works on binary classification. And so for this particular scenario, in identifying spam email or a normal email, it is advised to use supervised learning. Why? Because it is more advanced with respect to our scenario and uses labeled data. Labeled data is nothing but you're labeling an email where either it is a spam or a normal email or a legitimate email. Spam, normal. Spam, normal. So you are categorizing the classification with a labeled tag or a data in the supervised learning. So you know what you're doing with respect to supervised learning. Whereas in the linear model you have a drawback with respect to only binary classification. So there comes a drawback. And then in the unsupervised learning you cannot do this because since it doesn't suit that purpose, because there are only two conditions, spam email or normal email. You're referring the tag in the supervised learning that will be giving more accuracy with respect to plotting my data. And so that's the reason I would be going with supervised learning and not the linear model or the unsupervised learning. Where I will be going for unsupervised learning is if at all my network is going to have a malware attack or a 0-day attack, uh, a thing which I'm not aware, I will go with the unsupervised learning condition or a formula. See, all these models have their own function, their own arithmetic function or a formula to process. Say for example, let me show you this one. I hope you are guys able to see. Maybe this is like overlapping. Let me put it here itself. Yeah. So yeah, now as I told, we went with a scenario of spam email or a normal email. So now we are focusing on the traditional AIML part. Inside the traditional email part, we tried to use different models or the different algorithms used. So we considered linear model for our spam email in identifying whether it's a spam email or a normal email. So when we check the linear model, so this is the equation they come up with. This is the equation they come up with. So I did try to study like how they come up with that formula. It was interesting, guys, but it takes really a lot of time to to explain these things. Or like I'll at most I'll try to explain this particular formula or the condition how they came up in the next session, when we explicitly focusing on the linear model with the use case. Yeah, now also we are considering, but maybe in detail I'll explain in a separate video or something like that. But so you need to understand how they have come up with different algorithms and different formulas. So when I am so my requirement was I need to identify a machine which is coming with a spam email or a normal email. So now I am considering I am running inside that. So I have got the this is the victim machine or the user machine. Now I am in my lab. I am putting this condition with Ubuntu OS or Linux based OS, and then I have my Python. I have my Python code with Python AIML libraries, and then I put the input variables as my I put my input to that Python code, and then I get the output. Here I am using traditional AI or ML, traditional AI or ML, and then I'm getting the output. In this particular scenario, like in identification of the spam or normal email, I need to choose which model is the best one. I can use linear model, I can use supervised learning, I can use unsupervised learning, but from the input variables x and y, say let's say spam is I mean spam is y variable and x is the normal email variable. I am in my Python code, I am defining this x and y variables with a number of counts, or like with respect to this formula. With respect to this formula, maybe I'll show that. So with respect to this formula, and I get that output. So what will be my condition if I use linear model? How will my graph will come? Because you're having the variables with x and y, right? So what will be my output if I use linear model? What will be my output if I plot supervised learning? What will be my output if I use unsupervised learning? So our ultimate goal is to find which model is have the highest accuracy. That model should be used to get to our requirement. So this is the traditional AIML approach with respect to different models of the traditional AIML for our use case. And then in this particular scenario, our ideal model would be supervised learning. Supervised learning. So this will be having the highest accuracy. So I will be using this particular supervised learning model in identifying the spam or normal email. As I told you earlier, you can use linear model also, but the accuracy when you compare with linear model or the supervised learning, that is the supervised learning will be giving you the highest output. So I have to use that particular model. And how do I come up with that logarithmic function, or the exponential function, or the the output is all based upon these formula. I cannot explain these formula. These are all like mathematical formulas. I cannot explain these. You have to remember as a fact just to implement in your scenario. But this is like a very basic workflow example with respect to traditional AI ML for a spam or a normal email scenario, and which model is like ideal to choose and get the accuracy output. So now we discussed a generic difference between the traditional AI ML and the generative AI. Now let's see a diagrammatic difference between this traditional AI ML approach and the generative AI ML in cybersecurity. So let's differentiate it. Now you have your machine. Here also you are having your machine. So this is traditional AI or ML, and this is generative AI or ML. Cybersecurity. So now from our machine, this is like the practical workflow which you are doing, not the user perspective, the artificial intelligence perspective. So you are having your Ubuntu OS machine, which is running Python code with Python libraries, which we will be covering later. And our scenario is to identify whether the mail is a normal email or a spam email. In this scenario, we are going to use traditional ML only, because this is a predictive approach. And now this Python code for this particular condition will be fit, or like will be like compiled with respect to x and y variables. Your x is normal variable, normal email, and your spam is y variable. And with respect to linear model formula, if you use a linear model formula, you will be getting a particular output. And if you plot that particular output, what is the accuracy? So accuracy is less in linear model, and so we are going with supervised model. So in supervised model, you have a particular formula or a function. It will be you going to use any one of the sub formula or the condition. So in generative AML, you will be having your LLM, large language model, and then you are trying to generate a malware attack using this LLM, and it will generate. And this is basically just to, like, it's a like a test environment in order to make sure that when a hacker is attacking, you should differentiate which is it's an hacker or a normal user who is trying to retransmit his packet. So similarly, this self-sustained generative AI will be generating like a attack just in order to make sure, like, you're testing in a lab environment to identify the differentiation between a normal traffic and a DOS attack, something like that. So these mostly used in like lab use cases or like an actual attacking, whereas in the traditional AML it's more of a predictive thing. So you have to to summarize, it's like more predictive, and this is like a more creative. Okay, in next class maybe we'll discuss what is LLM, and we'll have some fun with respect to different LLM types being used in today's world, like ChatGPT, Gamma, and all. Let's see that in the next session.